So we're
I
like,
got through the reading and struggled.
my quiz says permission. Click OK to start your quiz, or click cancel if you do not wish to start.
Do you not wish to start now?
I wish I had 1 hour. 1 hour.
Let's reconvene at 10:15. Just kidding.
Look.
That's really late.
Now I need to get my punishment.
Jeremy, did you understand stuff?
I think so.
So like this is gonna looking to
We
the
use the second tab on that quantitative inference one a lot. That does most of the calculations for us. So.
Oh yeah, I need to find that again. I forgot about that. Okay, Raphael, you're in charge. That means you have all the answers.
Let's see how this goes. All right. So, per sample t-test. Yeah. Okay.
I got 2 for that one.
You already have the answer? I haven't even read the question yet.
It says, suppose we have
So when we were waiting, I kind of got started, but
Good for you. Good for you.
okay. Suppose we have a set of paired data and let D equals X after minus X before. The null hypothesis is mean. How do you read that? Mean D?
Mu difference? Is that what it was?
so this is that is what do you call that? So that's
Difference?
the true mean difference. That's the true mean difference in the test. The D with the line over it is the sample mean, and the S with the little d is the sample standard deviation for this hypothesis test.
Okay. So it is that the true mean difference is 0. The alternative hypothesis is the true mean difference is not 0. And the population standard deviation, sigma, is not known. Jordan collects a sample of size n equals 9 and computes D. Where is that D?
So the t-score formula would be 2.2 minus 0 over 3.3 divided by the square root of 9.
Okay, that makes sense.
That makes sense.
Well, I remember writing down that formula, and so I can see how he got those numbers. It really does make sense. Don't laugh at me.
Okay, so there's just one little problem I have.
What?
It's related.
The suspense is killing me. Come on.
Okay, so is this where we use the Excel?
No, not yet.
This one.
This
Yeah,
is just to calculate the formula.
I told you, I was not smart. I was just prepared. So okay, the formula should be what?
It is
Oh, I see.
D equals D with the bar,
So
right?
bar minus the mean, the true mean difference,
0.
which is the, yeah, so in this case it's equal to 0. And then the sample standard deviation divided by the square root of the sample size. So 2.2 minus 0, and then it ends up being 3.3 divided by 3, which is 1.1, and 2.2 divided by 1.1 is 2.
It's the
That's
same
what I got.
equation as last week's T equals, except the D replaces the X, and it's the true mean
Yeah.
instead of just the mean, and then the sample with the D.
Yeah.
You got 2.2?
2, just 2.
I got 2. Just
I was
2.
gonna say I just got 2. 2.2 is what D is.
The D
Yeah.
bar. What's that called?
Minus 0. The true mean difference, or the D with the bar is the sample mean.
Okay.
Okay.
So in this case, the sample mean they computed from the 9 subjects is 2.2. The standard deviation is 3.3. We're using the true mean difference equal to 0 as part of the test.
Yeah. So, if I understand correctly, it's 2.2 minus 0
Mm-hmm.
divided 3.3
Mm-hmm.
divided square root of 9. Is that correct?
Good job.
Yes.
Doesn't. Oh, never mind. They gave me that. Yeah, I got 2. Sorry, guys. I know I'm slowing down tonight.
You're
Oh.
good. Did you guys notice the teacher, how the announcement said that this was probably, we would actually use this in real life?
Real life?
This is what we would really use, and I just love that we've been studying stats for 6 weeks, and he just mentioned today that this is what we'll use.
That we'll actually use some of this.
Anyway. And this is what I understood the least.
I'm hoping to be.
Okay, let's keep going.
I'm hoping to be teaching in a couple of years. I'm not going to be using this at all.
Okay, number 4. The probability of obtaining a test statistic greater than Jordan's test stat is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
So you need the applet for this one.
Okay, so would you put the 0.0403 in the applet?
You would put it in the area at the top and highlight only the very right side.
Okay.
Because it's asking for greater than.
Oh, I see.
So
The
0.0202. Or
What is in T
nope,
distribution?
nothing.
Or the applet?
2.597.
I got it's 1.747.
Wait a minute. You put 0.0403 in the top, highlight the right, and you got 1? I got 2.
One. So at the top, the area is 0.0403.
Oh, how many degrees of freedom?
I'm in the probability applet. There are no degrees of freedom here.
Oh. I mean,
Yeah, Amber, I just realized, I was like, we're using the wrong applet.
but it didn't give us the other one.
No, so it's giving you the probability, which is the area the z-score, like if we get the z-score, we use the z-score to get the probability. In this case, they gave us the probability to get the z-score.
Right. But I mean, the test doesn't have the link for the applet. It only has the t distribution.
Yeah,
So this time I got 1.747.
Yeah, I saved it to my computer so I can pull it up whenever.
Are you sure you need that one and not the t?
I don't know when we would. Like they gave that to us last week and we didn't even use it.
That's true.
I mean, you could put that in there. Let's try. Let's see what it does. Because they don't give us degrees of freedom, so I don't know that we would be able to use that.
I have no idea. Unless we have to figure out the degrees of freedom. But
Yeah, they didn't give that to us, so I don't think we can use that one. Because there's no way for us to get degrees of freedom from the data, because we don't have a data set.
Yeah.
So I just used the normal probability outlet.
what was the answer?
1.747. I'm hoping it's right. If not, then
1.747.
So we need to determine the p-value.
Yeah.
no. Oh, yeah. So we need to determine the p-value.
But the p-value
So that gives us
the one on top in the probability.
Yeah, so the z-score is 1.747. So then we have to we use that in the p-value formula, right?
That's the
And
x bar
if I
minus mean, right? Like divided by. Nope.
No, that's
It's z.
Oh.
I should just. Okay, so it's z.
I have a question.
I think it's the z-score.
Guys, so if you use the Excel thing, and should you use the null hypothesis and type of test to get the p-value?
Are you asking us?
This is.
Yeah.
So this is like this particular question is there's not a lot of calculations involved because they only give you a couple of numbers. I was under the understanding that it was just the z-score to the right. Is that
Did you
z-score?
use
But
the Excel, Raphael?
Yeah, I'm saying, see that in Excel, you can put like null hypothesis, and I'm putting 0.0403 and type of test greater than, and it gives me the p-value.
Okay, what is it?
On the second tab, per sample t-test, and then you can put the mean. The mean is 2.2, standard deviation 3.3, size n, null hypothesis 0.0403, and greater than.
Wait. So the test statistic is 0.403, right?
That's the null hypothesis.
The null hypothesis is simply equal to 0.
Oh yeah.
The alternative is not equal to.
I understand. How do you solve these?
I'm pretty sure it's just the area to the right of the z of. It's that area. But
Is somebody's fire alarm beeping?
What?
I don't think it.
Sounds like somebody's fire alarm is beeping.
I was hearing it too, and at first I thought it was in my hall, but mine's not flashing.
Okay, so do we want to do 1.747 for that answer and see what happens?
we could give it a shot and see what happens.
Okay, let's just keep going because there's 19 questions. We might have to break our streak of 100%.
That would hurt so much.
Use the data file to answer the next 6 questions. Perform paired samples t-test and SPSS. Be sure that the test was group 1 minus group 2. Use a null hypothesis of that 0 and alternative hypothesis of not 0 and level of significance of 0.10.
Guys, so question number 4 said 1 point.
747?
747.
Wait, 1.7?
Or 7.
1.747.
Okay. That's clear then. 2 people at the same time. Okay. So here's when we copy these.
Are we on? Are you guys on question 5?
Yeah.
Okay.
Excuse me. The level.
So do you guys know how to do this one?
We need to take that info.
So make in column C, type difference in C1, and then in C2 do a formula equals A2 minus B2.
It already has the.
It has the 2 groups, and then we have to subtract group 1 from group 2 for each row.
I mean, on the SCSS, it already has that on it.
Mine didn't. It only had the 2 groups. It didn't give me the difference.
Yes. Oh, mine has the differences.
Difference?
Yeah.
Yeah, mine
It's a
didn't. I had to
paired
make it.
sample t-test, not the 2 sample test. The second tab rather than tab.
For the chapter 12 data A1 page.
Oh, I mean on the other Excel.
Yeah, but you have to do this calculation first and then copy and paste it over into the other one.
But it already has the differences. Doesn't it? Quantitative inference procedures Excel sheet?
No.
Am I not understanding that correctly? Because
we have to make the difference calculation ourselves first.
And then where do we put it? In variable one?
So did you open that chapter 12 data A1 page?
Yeah, I have it.
All right. So then we have to it says group 1 and group 2, right?
Right.
And that's all it says?
Yes.
All right. So we have to calculate the difference in that page.
No, you just copy that data and you paste it as values in the paired sample.
I'm going by what the reading says. That's what I'm going by. I'm not going by anything else. I'm just going by the chapter.
Oh, I get it.
So I got question 5. I got 0.407. Did you get?
Me too.
Almost.
Cool.
Let me see real quick.
407.
Okay. I feel like just entering a number shouldn't be so hard, but it's got me off. Why is it so hard?
0.407.
Yeah.
So 0.407, that's the T test, right?
Yeah.
Sweet, that's what I got. So you could just copy it in there and it already has the formula on there.
Yeah. I'm just going. I'm just going by what the reading was. So. So for p-value, I got 0.689.
Almost there. 1 second.
Oh, me too.
Point 689.
I can hear your crunching, Raphael.
What are you
Sorry.
eating?
Okay, we good for question 7?
Yeah.
So then we failed to reject.
Yeah.
And suppose your alternative hypothesis is instead the true mean difference is greater than 0. What is the correct decision based on this evidence?
I say C.
Um,
Oh, no. D. B. B.
I gotta get my note. 1 second.
so we would still fail to reject. 'Cause it's still greater than.
So B.
B.
Although it's only 21. How many samples do we have? It's 20. Is that big enough?
What?
I didn't do a histogram to look at what the data looks like.
But isn't it based on the level of significance rather than in the samples?
Yes.
Yeah, I'm just saying it depends if it's normally distributed, but I mean it's still greater than the level of significance because we're looking at 0.1, right? And when I changed the type of test to greater than, the p-value went to 0.344. You guys, is it the same for you guys?
Yeah.
So would we have insufficient evidence that the mean of the differences is greater than 0?
I understand, guys. I understand.
Oh, good. You want to clue us in?
So is it B?
I think it's B.
I'm going to go with it.
Because it's the p-value is still greater than 0.1, right?
Yeah.
Right.
Yeah.
Oh wait. Yeah. Okay.
The question differently worded is, do you fail to reject or do you reject? And we still fail to reject it because there is insufficient evidence.
That makes sense. That makes sense.
I feel like I take these notes when I'm reading stuff, and then we have these meetings, and I have to go in and like add or change my notes, like because I do them all on Google Docs. So like we're talking, I'm like, just gonna change this note here.
I left all my notes in my car. They don't really want to go.
Well, like I do, because like Monday isn't a school day for me as far as like when I like with my work schedule. So the easiest thing is I do like the prep for this class during my lunch hour. And so the easiest thing is to just put my notes on Google Docs. So.
Nice. That's a good idea.
So the easiest to do is just eat your lunch.
Well, I can kind of like my
I
job
would
is a
do
little
that. I would do-
eat time. So I use my lunch hour to do school and then I eat all day.
Nice.
Sorry.
Well, that seems to work.
Mm-hmm.
Okay. Use the data file chapter 12 data b1 .lxsx to answer the next 8 questions. Perform a paired samples t-test in SPSS. Be sure that the test does go group 1 minus group 2. This data comes from nosocomial infections. The SX. The null hypothesis is, well, this is what we need. Null hypothesis is 0. Alternative hypothesis is different than 0, not equal to 0. Level of significance is 0.01. Which is greater?
So n would be greater, right?
Greater than... Oh, it's going to always be greater.
Wait, and is always greater? What did you just say?
And is always greater? Raphael.
Yes. It is always greater because n
What
is the
was that?
sample. N is the sample size, and the degrees of freedom is the sample size minus.
-1.
Okay.
So n will always be greater.
Look at you go. P-value. I got 0.0006.
Hey, me too.
Oh, I got a different one.
I got 0.000 no 001.
Me
Did you
too.
get that, Jeremy?
Yeah.
Oh no, actually I got that sunshine in my pocket.
Oh, wait. I totally got. No.
So your null hypothesis is 0. Your type of test is not equal to.
Yeah, that's where I got. 0.0012153112.
Yes.
Yeah.
Just to round it.
So you guys got.
So
What
in
decision
this
did you make?
case, we would reject, right?
No, we failed to reject.
If
Even the-
p-value is less than.
Oh yeah,
P-value
yeah.
is less than the level.
You're right. My
There's
bad.
an extra 0 in there, Raphael.
Yeah, I have a problem with my eyes.
Question 12. You decide.
Sometimes I do not see the zeros.
So it should be on a. Oh yeah.
We on 12?
Okay.
Right? We reject the null
Bye.
hypothesis and go to
What?
nothing.
Yeah.
Just keep going.
Die to try another alternative hypothesis. This time you use true mean difference is greater than 0. The same level of significance. Did the p-value increase or decrease?
Decrease.
It decreased.
I don't have I have 2 screens, but it's not enough. I need like 4. What decision do you make? Reject. Rejected. $14?
Yeah. Question.
Yes.
Based on your response from previous question, what conclusion do you make?
Have sufficient. I have no idea. A. I do better with numbers than words, just so you know.
So it
Did
would
you notice
be
that, Jeremy?
what?
Did you notice that? So I think that is C, but it's kind of tricky because it says we have sufficient evidence that there is a mean difference between the two groups. Doesn't say groups.
I'm
gosh.
sure that's just a typo.
But
There's also not there. There's also not a period on D, so it's just some teacher's aide not doing their job. Can't stand teacher's aides.
We're live.
I guess we have to have charity.
15?
So
You're on C?
why do you think it's C?
so we're failing.
Because you said so. Just kidding. Well, mostly kidding.
We're
Mostly kidding.
I think we have sufficient evidence. It's one of the two we have sufficient evidences. So
I know that for sure.
Now, if there is no mean,
I know we're
that means difference is 0.
Do that again?
If there is no mean difference,
so we fit. So it's not. It's and we've proven that it's not equal to 0, right?
yeah, we're proving that it's greater
Because
than.
we've rejected.
Okay.
You see
Yeah.
that our p-value was
Lower.
it was lower when it was greater than 0.
Right.
So would it be A?
No, I think it's C.
You think it's C? Okay.
Yeah.
Question 15. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
It looks like greater than.
Greater
Yeah.
than.
See, less than, it goes up. Yeah, it's greater than.
And it doesn't depend on the problem, right? It's just all the time.
Why do you say that?
I guess.
I don't know.
To test if we really know what we're doing.
Or to answer my question. Does it depend on the problem or not? Why are you laughing at me? Stop laughing at me.
What happened?
Oh my gosh. Never mind. Let's move on.
Okay. It doesn't depend on the problem. That's what it says. Depends on the alternative hypothesis in general. Okay. Let's remind the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2. Input your answers below. What is the point estimate for the 95% confidence interval? Well, that's the point estimate.
Um,
I don't know about that.
The sample standard deviation is a point estimate of the population standard deviation. Sample mean is a point estimate of the population mean.
So would that be the 960?
The what?
You know that the confidence interval for 95% confidence interval is 1.960. You know how they gave you those three? For 90% it's 1.645. For 99% it's 2.576.
Are we still using the information from that?
I think it wants us to.
On the two
I haven't.
spreadsheets, right?
2, 3, 6.
I have, because on that confidence interval, it gives you the upper and the lower.
Yeah. So would that be the answer? The confidence interval? Oh,
Are we using greater than or lesser than? I left it on greater than.
you
But
did.
so for the point estimate, it's 1.960.
What is your confidence interval there?
Huh?
95?
Well, like it's determine the 95% confidence interval for the mean difference between the two groups.
What do you mean?
Where it says information. How come the one that we will use in real life is so confusing?
Right? The one and only?
One and only.
Bear with me, my quiz, like my Chrome just like shut down. So
No. Well, we could guess and see if we got it right and move on.
But I mean, what are you gonna guess if it's not a multiple choice?
You know.
it sounded like a good idea.
Jerry said 1.960. That's a number.
So I thought it was 1.960 because that's the point estimate for a 95% confidence interval.
I'm good with that.
But then we have to calculate the
you were
margin of error. Which would be 1.960 times. The formula I have for margin of error is it would be the 1.960 times sigma over the square root of the sample size. Do we have that information? Sigma is unknown in this, isn't it? Yeah. I don't know how to get 17.
Did we find the z-score already for this question? I mean, for the... We don't have.
Oh, could it be?
Yes. Reminded me of the song from Zubumafu. Nope.
What did we decide on for 16?
I don't know.
Or is that what we're still on? Sorry.
I think 16,
I just don't want-
17 kind of at the same time.
Oh, what is the margin of error? Okay.
You look at 18, input the lower bound. Does that mean the lower?
Would that be the 5.303?
Yeah, and then the upper would be the 18.
Well, it seems like the. What is the point estimate?
What is a point estimate?
Is that the lower bound? Why doesn't it say lower bound? I think your washer finished.
Yep, it did. I gotta go start the dryer now.
So the mean difference. Okay. So the mean difference between the two groups is 11.955.
Yeah.
So would that? Oh, okay. So if that's the case, I'm pretty sure. I thought the point estimate was 0.960, and then the margin of error would be 1.960 times 11.955 over the square root of 22.
I don't know.
So that would be margin of error would be 4.9.
We have all the info on
4.996.
You're right.
because the z-score is the t. So to get the margin of error, it's 3.737 times
Oh yeah.
the standard deviation of 15.003 divided by the square root of 22, right? Is that how we would get that? Is that what you were saying, Jeremy? I didn't mean to cut you off, sorry. I just got so excited.
How did you get the point estimate?
I didn't.
So
Margin of error as 11.953 though.
because you need the point estimate before you calculate the margin of error.
Yeah. Then why would you need the point estimate?
Because it's You know that Z asterisk
Yeah.
isn't that the point estimate? That's dependent on what your confidence level is,
Okay.
or your confidence interval. So the formula for 95% confidence interval for mean with a that's with a known. Oh,
So
that's
it's
X1.
and you're thinking the point estimate is 1.960 still, or are you thinking something else?
Okay, so I wrote this note for lesson 10. Formula for a 95% confidence interval for a mean with a known sigma is x bar minus 1.96 times the standard deviation divided by the square root of the sample size.
I have that too, right here in
And
front of my face.
so the point estimate is that 1.96 though, isn't it?
Yes.
Okay. What'd you get for the margin of error?
I'm putting it in right now.
Okay.
But instead of I'm putting it in as something else because it's wrong. The first one I got was 11.953, but I think it might be
That's
6.
the mean.
What? That's what the z-score, or the p whatever. But if we're going with the point estimate, then I got 6.269.
I still don't know a reference to the point estimate.
Well, in lesson 12, it doesn't even have the word point estimate, so it's not lesson 12.
It did?
Huh?
Did lesson 12 talk about point estimate?
No, it didn't. It
I know.
didn't even have it.
Guys,
Yeah, they go
it's
back
right
and
there.
forth.
It does in lesson 11.
So,
Yeah.
you know what's a confidence interval?
Okay, yes.
Estimate is a point estimate plus or minus the margin of error.
Wait,
Yeah.
the point estimate is that. Say that again?
A point estimate x bar plus or minus the margin of error. That's the confidence.
Yeah.
So what we're looking for is the mean that we get.
So what do we need to do? I'm confused.
So what is the margin of error?
What is the margin of error?
Yeah.
Well, it depends on what numbers you're using. If you're using the numbers from Excel, then it's 11.953. But if you're using the 1.690, then it's 6.269.
So I have the mean as 11.95.
Right? That's what I got as the
In
margin of
Excel.
error.
Yeah. So 11.955 plus this plus this. Ah, it's weird.
I'm so confused right now. Lesson 11 talks about confidence intervals and point estimates.
Lesson 11?
Yeah.
At least now we know what the point estimate is.
You might, but I'm still confused. You made me more confused.
I was gonna say I'm quiet because I am lost, like full on lost.
When the sigma is not known, we replace the population standard deviation sigma with its point estimate. S, or 8. I think it's S.
Oh no. Oh, we got.
It's probably just like 1.960 and we're just trying too hard.
It's not.
Darn.
I already know it's not for sure.
Did you submit it already?
I did.
What?
We also got 4 wrong, 15 wrong, and then it's definitely not 1.960.
What?
So did we get 17, 18,
Alright.
19 right?
We got 18 and 19 right.
But not 17?
Not 7. What did you get? Well, I didn't. I answered something else for 17 to see if I did the right thing, and I didn't do the right thing.
What did you? I put 11.953. Is that what you put?
I did not put that, but I will this time.
Well, I don't know if that's right, so I don't suggest that.
In the margin of
What did
error?
we put for 18 and 19? Because I'm still lost.
Okay, so let's see. So if I understand correctly, we need to copy the differences and paste them in the one sample t-test, right?
Right?
As values. Is that correct?
Are you doing the one sample t-test thing?
Yeah. Because just because I found that in the reading.
Why isn't it letting me do that? There we go. And then you put it in the quantitative descriptions thing. Oh no, the
In the
one
first
sample
tab,
t-test.
one sample t-test.
Yeah. So 5 to 26.
You make the confidence level 0.95, the null hypothesis. This is what I'm doing. Null hypothesis 0. And the type of test, I put greater than.
Type of test is greater than?
Oh no, it's deep, not equal. My bad.
Huh?
It's not equal.
Not equal to?
Okay, and that doesn't change much of what we thought. Well, if this is correct, then the lower bound should be 5.303 in question 18.
That's what I got. 18.607.
Yeah, in the 19.
Yeah.
And then the margin of error. The margin of error, the standard error of the mean? I'm not sure about that.
So I put that for one of the homework quizzes, and I got it wrong.
Yeah. Maybe we should need to calculate it.
Um, I'm giving 3 different answers for the margin of error because I have 3 different. So in lesson 10, it says what you were saying, Raphael, that the confidence interval is actually a point estimate plus or minus the margin of error. I understand what you're saying now.
Yeah.
So to find,
Do you remember that formula that we did to find what was the middle one?
what?
It's just I don't remember, but I remember that we made a formula, and you did it in a way, and I did it in another way.
Oh, yeah. Hmm.
Okay, can.
I really need to take better notes. That was instead of the z-score, I think. I mean the z-score when you knew the z-score, but not the x. Because it's x equals something plus something times something.
I bet this equals something.
It does. It equals something. But yeah, I don't think that pertains to this because we're not even finding the z-score or the x, are we? I guess x bar. What does x bar stand for? The.
Sample mean? X bar is B
Sample
bar.
mean.
So is that what we're trying to find?
Yeah.
Oh yeah, a point x estimate x bar plus or minus the margin of error. So it's x bar equals that number plus that number times that number. I just don't remember what that numbers are. I didn't write it down. I feel like this shouldn't be so hard.
I don't know. Is it really that hard?
Probably not.
We're just overthinking.
Mm-hmm.
Okay.
Oh. Let's see something.
Good. Where?
T times S standard deviation divided per root Okay, so D bar is, according to my calculations, D bar is the point estimate. So
D bar? Oh, okay.
11.955 should be the point estimate.
Mean?
Yeah. And
Okay.
how I did it was in lesson 11, there's this part of confidence intervals.
Mm-hmm.
And then when you know that, actually,
Was it not less than 10?
I went to lesson 11 already, but
So you're saying the point estimate for this is 11.955?
x minus t. I'm trying to use this formula that says x minus t times s divided square root of n.
Oh. So that's the formula for a 95% confidence level for a mean with a known standard deviation. So the mean minus the 1.96 times 15.003 divided by 22, square root of 22.
Yeah, kind of
But
like that.
that's just the confidence interval, and so yeah, the point. So the point estimate would be the 11.955 then, and the margin of error would be
11.953.
That was wrong.
So that was wrong?
Yeah, because I had submitted my first one with the 11.953, and that was wrong
Gotcha.
for margin of error.
Okay, let me submit this to see what happens.
Hey, before you submit,
we're gonna have to go back over all the answers.
you already submit it.
6.652. I'm gonna try with that.
What?
6.652.
For number 17?
Yeah.
6.652.
I'm submitting.
I
Oh, I
So-
go one wrong.
was gonna say you should.
Oh, really? Yeah.
Question 4.
I was gonna say change question 4. I was gonna have you change it to 2.597.
And 15.
2.5. 15 is
Okay.
2.5.
So 16 is I got it right, and 17 I got it right.
What?
Cool.
What are they? So 17 is 11.953. And 8.
No.
5.
I mean,
955.
995. That's 16.
Come on.
And what's 17?
16 is 11.955.
Yeah. Now what I did was, see that we have the confidence interval? I just subtracted 11.955.
T?
I subtracted the mean
Oh, okay.
from the upper bound and subtracted the lower bound from the mean, and I got the same value in both.
So 17 is 6.652.
Yeah, you get that? Now the
Yeah.
question is 50.
Excuse me.
So 15 depends on the problem.
Amber, how did you get 4?
I used the T distribution applet. Did the same thing, but I don't know if it's right.
And put in.
The same thing as in the other applet. Sorry, question 17 is 6.692.
How many degrees of freedom did you use?
I just left it
In,
at 3, I guess,
with
or didn't
3?
touch it.
And then you put the area 0.0403.
Yeah.
I got 3.472.
Wait,
Make sure it's not right.
Jeremy,
Yeah.
you used your first shot already, right?
Yeah. What do you want to know?
Did you use yours?
For which one?
For the meeting quiz?
Which question?
No, I'm saying, see that I submitted the quiz? I already submitted once. I have one more shot. Jeremy already submitted once. He has one more shot. Amber, did you do that?
Yeah.
Adriana?
Yeah, that's how I knew that.
Okay. So wait, so question number 2 was, okay. Question number 3, we got 2.
There's 2.
Question number 4, we don't know. Question number 5.
Wait a second. I got 16
Where
and
is it
17 wrong.
Huh?
I got 16 and 17 wrong. Why is that?
Did you put 11.955?
Oh, no, I'm dyslexic. I put 995.
So 16 is 11.955 and 17 is 6.652.
What?
That's what Raphael said.
What?
And he said he got it right.
You told me, and I totally didn't get it right.
All right, we're starting. Let's figure out 4. What was Amber? Did you get 4 right?
No, I did not.
2.597.
No.
So using the T applet, I got Raphael, what did you get for 4? Or did you get it wrong?
I'm you know what? I'm working on the questions and the other questions. I'm still working on it. 0.407. Six.
Okay, I see how you got 2.597 there.
169.
Yeah, I don't know what 4 would be. So Raphael, which ones are you working on? We should do this together.
Okay, question 7. Fail to reject. question 8.
Oh, you're putting the answers in?
Yeah. That's why.
8 is B.
Okay.
Did you?
9, N, 10,
Is 0.001. 11 is reject.
11 what?
Reject.
Reject.
11 is reject.
12 is
Oh.
decrease.
12 is decrease.
13 is reject. 14 is D.
D.
14 is C.
C.
Sorry, I meant C. 15 is
15 we got.
We got wrong.
15. Is there not enough information?
not. Depends on the problem.
So it says in general. Does that mean there's not enough information and depends on the problem?
Is that tricky?
What?
Is it being tricky?
Have we all picked like different answers for that one?
I think we all picked D, right?
We picked
Oh, when he
D
said it
and
was
D
wrong,
is
I
wrong.
changed it to less than, and that was wrong.
Oh, you did less than?
I
Was
think
after
it's
he
not
said
enough
it.
info.
11, 9.
Must depend on the problem.
It could be not equal to.
Yeah.
Can we find that one?
But the thing is, like, the not equal to is bigger than greater than for the problem we did.
Yep, it is. I vote not enough information.
Yeah, that's what
Yeah,
I
that's
changed
what I'm
it
saying.
to.
Okay, 16 is 11.955, not 995.
Yeah.
And
17.
6.652.
Yeah.
Hold on, sorry, mine froze.
Is 5.303, 19, 18.607.
So the only question we don't have answered is 4.
955.
Yeah, 4, and we're guessing on 15, but it seems possible.
I'm pretty confident that we got 15 right
What did you guys say? 6?
this time around. 17 is 6.652.
And 16 was 11.955.
Yes.
Okay,
My like internet is lagging, so the page keeps.
no,
So number 4. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. We have to use this probability to determine the p-value for the hypothesis test.
So who's Jordan?
who's
That doesn't
Jordan?
matter. For all we know. It's getting late. Names don't matter anymore.
Okay, but I mean, it's the probability of obtaining a test statistic greater than Jordan's. What's the test statistic, Jordan?
Well, if you look up at the information for the questions,
Also 2.2.
it says the null hypothesis is blah, blah, blah. The alternative is blah, blah. And then it says Jordan collects a sample size of N9, computes D bar 2.2, sample standard deviation of 3.3. So this is all Jordan's fault to begin with. Test statistic is 0.407. The p-value is 0.689. No, wait, hold it. I got ahead. The test statistic is 2.
Who is
Oh, yeah. So, if you put 2 in the t equals, the area is 0.697. But that doesn't do anything. So if we put it in 0.0403. So we've got a t-score of 2.597. How do we convert that to a p-value?
We had what?
Calculated by finding the...
In our first answer, we had
Oh. So the p-value is calculated by finding the area under the normal distribution curve that is more extreme than the z-score.
oh.
I thought it was...
Guys, you're so serious.
We got...
Did you say you have the t-score? Jeremy, did you say you found the t-score?
Do you have the formula for the p-value?
I don't know it.
I thought I wrote it down. I need to make a notes page that just has formulas.
Me too, but mine's not updated. I only update mine like every test.
So, Jeremy?
Yeah.
Remember that you said you put in the applet and then select, enter the value and then select graded area. Well, that's what they did already. Look, it says the probability of obtaining a test statistic greater than Jordan's is 0.0403. That's what I got when I entered T2 and 8 degrees of freedom. And highlighted the graded table.
You put 8 degrees of freedom and T2.
Yeah, and you highlight the greater tail.
Yeah.
And you get the area, which is 0.0.
So what's the probability to determine? So how do we determine the p-value from all that?
Oh.
Maybe it's, I don't know.
Because the p-value, normally we just click on the area. Oh, there's a way of...
Could it be 0.
I thought I had that.
0.04258.
Could it be 0.95 or 960?
What's the significance level? You don't know this. It's kind of cheating, but I found a p-value calculator.
Uh,
I was hoping it would help us find the answer. I mean, get to the answer. I have the answer right here. I think.
Okay.
Well, this calculator says it's 0.0402. Well, 3. So the test statistic is the p-value according to this calculator.
which would be 2.
No, 0.0403.
Isn't that what it is in the equation? Or like it says statistic greater than Jordan's test statistic is 0.0403.
I don't know if that's the right answer. I'm just telling you what I found from this little calculator.
Well, that's the number that it gives us in the problem.
Oh my god. I think the p-value is 0.080. 0.081.
How did you find that?
But I'm not sure.
So the probability is, it is the area. Value is the probability of obtaining a test statistic at least as extreme as the one you calculated, assuming the null hypothesis is true. The p-value is the probability that we would get a z-score that is as extreme or more extreme.
Guys,
Raphael's answer is right.
What
I'm,
is it?
I'm going to sacrifice.
No, I'm telling you, I already submitted it. It's right.
What is it?
Raphael's answer, the 0.081.
You took my
What?
place. I was going to sacrifice.
So what's going on? What's the
Guys,
number?
I'm running on like 3.5 hours of sleep, and I have to be up at 5. So yeah, I took it and hoped that it was right.
So what's the number?
I was going to sacrifice.
0.081.
So wait, hold it. I can't hear. Sorry. What is the number, Adriana?
0.081.
0.81. So how did we get that?
I don't know.
Imagine that.
So Raphael,
Imagine that you atone the sins of the world.
no, how did you get the answer? I'm not imagining. how did you do it?
She stole my sacrifice. Okay, so this is what I did. Go to the pair sample t-test for means.
Okay.
And then what you're gonna do is you're gonna put mean 2.2. Standard deviation.
Oh wait, are you in that quantitative inference procedure thing?
Yeah, just erase the variables and the differences. You don't need that now.
On this one sample t-test?
Yeah. Just erase them. And then enter the mean, the standard deviation, and the sample. You should get 2.2, 3.39, right?
Mm-hmm.
Now confidence level is 0.95. And the null hypothesis is 0, according to this. Yeah?
Are we doing greater than or less?
Now you're not doing greater than.
Oh, look, there it is.
Your hypothesis is not equal. So
Gotcha.
not equal.
See it. Got it.
Now if you change the type of test to greater than, this is what happens to the p-value. You get Jordan's p-value.
Right.
And now if you change it to yours,
That makes sense.
Sorry, I just barely opened it up again.
oh,
So we have to type in N9. The mean is 2.2.
yeah. Standard deviation is 3.3.
Okay.
The confidence level 0.95, null hypothesis 0, and,
Uh-huh.
and type of test but greater than.
Okay.
Now you got the T of 2, you got the
Uh-huh.
degrees of freedom of 8, and you got the p
8.
value that Jordan got.
0.040258 and all that.
Which is 0.0403. Now, if you change the type of
Yeah.
test to not equal to, which is your alternative hypothesis, according to the information above,
Uh-huh.
you get 0.0805 in the p-value, and you round it to 0.81, and that is the correct one.
Good work.
I was going to submit
Good
that
job.
answer in Sacrifice.
We know.
But so
Someone
So,
stole my
oh.
grades.
So you need to change it to greater than because of wording of the question.
Yeah, the question said that Jordan got greater than. Now, what would you get with the not equal?
Got it.
It's just that the questions are worded in
Yeah.
a way.
Yeah.
Why do they do that? Nobody talks like that.
Well, just think about it. Imagine what would happen if there were two groups.
Okay. I'll see you guys on Thursday.
Not two groups, but two groups.
See you later.
That's the same that if you say approximately normal.
Right.
Normal.